All right, welcome everyone to the Twin Cities Less. This is the July edition. So we're getting together today to hear from Victor Gurgic. Um, First, I'm going to go over a couple things about our community. Then I'm going to pass it off to my co-host Sam Bryson, and he'll pass it off to my other co-host Vlad Bushin, and he'll introduce our guest speaker. What I wanted to mention first is some really great stats about our community. We've grown 20% over the last month. So we are at 200 members. We're now at 240 members. So that's a really great improvement. And I think it just speaks to the fact that we're, bringing great presenters here and giving a lot of space for people to ask questions and learn. Um, and just the overall interest in large scale Scrum, especially that's growing in the Twin Cities area. We do invite people from all over the world, just like the New York City large scale Scrum meetup with Gene. So please invite whoever you like to these meetups. Um, and again, yeah, this is just a place for people to come together and learn about less. It's a safe place to ask any type of question that you want. We try and bring in topics that are not so much explaining what less is, but like topics that are supportive of less. They help you implement less. It might not be something you would expect to hear about, but when you dig into large scale Scrum, you realize how important these topics are. Let me admit a few more people in here. And that's pretty much all I want to say. So, if you're interested in planning, you can join the planning committee. Just reach out. That's all I have. So I'm going to pass it off to Sam, and he's going to give you kind of a look forward for the Twin Cities Less community. Thanks.
Thanks, everyone. Hey, my name is Sam Bryson, one of the co-organizers here for Twin Cities Less. So just wanted to kind of share our approach. And first, thanks again to Victor for making time and preparing for the presentation today. One of the approaches that we're going to try experimenting with this community is kind of build a little bit of pipeline for folks that are working on a white paper or a case study as a part of their journey with less and coaching and other things. We've had James, who's on, did a presentation as a part of his kind of preparation for a case study that got a whole lot of great feedback. So what we're trying to do is kind of open up our pipeline there and reach out to folks that are potentially working on case studies or write-ups related to less. Victor has been kind enough, in addition to helping us out with the presentation today, to kind of give us a few folks that he's been mentoring that we're going to try and bring in for future sessions too. So very excited about the approach there, getting some good feedback in it, and looking forward to share more as well. The other thing I just have to mention really quickly is congratulations are in order for Dave accomplishing the Certified Less Coach. Posted on LinkedIn there. So I just want to spend one moment to acknowledge, he's been a great part of the community, inspiration to me and to others that have had the opportunity to work with him there. So take a moment to thank or to congratulate Dave on that accomplishment as well.
Thank you.
Congratulations, David.
Thanks.
All the best, David.
All right, and I'll turn it over to Vlad to do the intros.
All right, thank you, David. Thank you, Sam. Today, with a great pleasure, I'd like to introduce Victor Gurgic. And Victor is an agile coach, software developer, and certified LeSS trainer with 17 years of experience in delivering enterprise system and agile adoptions. And over these years, Victor was a freelance architect, coached other architects and teams, and brought agile adoption and development practice to numerous huge and famous organizations in Europe and Far East. I was very fascinated about this. The list includes the Dutch Chamber of Commerce, Municipality of Amsterdam, kind of like a Dutch Amazon. It's a bol.com, and also a huge Dutch railway management company, ProRail, Port of Rotterdam, Thales Hong Kong, Splunk in Shanghai, Hutchinson Ports in Hong Kong, BMW in Germany, and others. It's just I didn't mention here. And in addition, Victor wrote numerous blogs about LESS, architecture, agile, technical solutions, DevOps, and I love the style and the presentation of it is funny, and it's actually very how to say, it's explaining things very well. And I like the blog leanarch.eu. And some of them on the odd-e.com. I hope that, Victor, you could share those wonderful resources with the community as well. And also, there's a lot of talks on YouTube related to managing products. And the one I specifically appreciate is on microservices organization, and the one on technical debt problem, which is kind of controversial. And the approach to that and look at that could be from different angles. I love the concept, the delivery, and the depth of the discussion. And maybe just to kind of to complete the picture, I know that Victor speaks on many conferences, Agile Confluence, Play Scrum, GoToCon, ASAS, Agile Singapore, and HAA in Shanghai. So, yet Victor teaches classes and train IT professionals. And this is a massive contribution to Agile community. I'm so happy to have Victor as our guest. It's a great pleasure for all of us to have a conversation and ask questions. Tonight and today morning for Victor, because he's in Hong Kong right now, 7 o'clock in the morning. And thank you, Victor, for coming over and sharing your thoughts. And over to you, Victor.
Okay, thank you. Thank you for having me. It's very nice to see that there is such a very nice community, and there are actually not that many that we have LESS communities which are so active, and so this is really nice to see that this one is quite active, and we have quite a few experience. Thank you for organizing this and having me here, and also for a very extensive introduction. So and it's almost uncomfortable. And so the one question regarding the questions that the participants might have, what's the rule? Or do they post a chat message or something, or?
So Vlad's going to moderate, and Vlad, how do you like to run this one?
Yeah, so I know that Victor, you wanted to show some concepts. We have an agenda here, and the agenda includes, well, first of all, the topic is why teams should share ownership of microservices and what that means in reality. And we are going to discuss the organizational setup with featured teams and how that works with microservices architecture. So agenda includes the ideas of transition from monolith to microservices. Maybe you can mention a book by Sam Newman, and the team organization and communication. This is kind of how our relationship started, what we start talking about. Descaling organization complexity, that's a part of LESS as well, and dependency management, which is also another great book by Eric Evans, Domain-Driven Design. And maybe in the end, we can get to the refactoring Microsoft's environment and data management. I will be looking at the questions. I have a ton of questions myself, but I will prioritize your questions in the chat. Please put them in the chat. And I will probably kind of stop once in a while and just give you an idea if there's some questions coming up there. Thank you.
Okay, good. Thank you. The reason why I ask is that I would love to have a question. So I'll try to not spend too much time on the slides. So, but it's important to give you first the context, and then we get as much as possible to the questions and the specific stuff. So the subject talks about the two things which are very interrelated, and which is microservice and teams organization, especially when the reason why and the benefit often touted about microservices is that you can organize teams in a certain way. And that seems rather straightforward, but in reality it's not straightforward at all. It's a very complex subject. So that you can, essentially what it boils down to is that each team owns a bunch of microservices, and that you can kind of independently from each other work on those microservices, and therefore you could kind of endlessly scale the organization, so you can have many teams. And so this is the claim, and we're gonna go into the detail of this claim and also a bit of a history of it. And part of relevant part of my background regarding this is that I've been software developer basically since 1998, and so it's a really long time ago. And in that time, I was spending some time with Corba in the beginning, not that much, and at that point I learned this this notion and this concept of having something called service-oriented stuff, and so that you have object brokers, etc., and they providing access to the objects, and then you can get information from it, etc. So that later on, what we got is I ended up in a enterprise Java Beans horror story, and so it was pretty bad. And then later on SOA hype, and so in that SOA hype, I became an SOA expert, and so because they saw that I could talk about it, I was giving talks about it at that time. That was a pretty long time ago, by the way, more than 10 years ago, 15 years ago or something. And but what I was mainly doing is not building some SOA or introducing some new techniques about it or whatever. I was mainly busy removing the stuff, so simplifying what typically companies introduce. So at that time was mainly SOAP and everything related to SOAP, and EGBs and ESBs. So getting rid of all that stuff, especially the ESB, Enterprise Service Bus, was a seriously horrible thing. And that basically killed kind of more or less the SOAP, in combination with ESBs, killed the whole SOA initiative, essentially. So at that time. So I was, ironically, SOA expert, which in Dutch, if there is any Dutch people, stands for sexually transmittable disease, by the way. And so that was kind of funny in the Netherlands to be called SOA expert. And instead of dealing with architecture and simplifying architecture, which I kept doing that, I started to move also simplifying product development organization. And nowadays also spend most of my time actually doing that. So talk about how to simplify the whole organizational setup. And that's exactly the place where the large-scale Scrum come into place. And now we're living in the whole microservices world. It will become relevant why I talk about this specific part of my background. And we will talk about, and I think Vladimir already explained about it. One thing which I will mention extensively is the concept of cognitive load. That's something which is becoming hot. So how can a single individual, a developer, or a team deal with such a massive amount of services in less? And how can they take this responsibility? That's a big question. And so the cognitive load is a concept, psychological concept, which is important in that. And Conway's law. I suspect that quite a few in the meantime know what the Conway's law is. And so I will mention that again, just in case. And but it's also extremely hot aspect of and the reasoning behind microservices and how teams are organized. And then we're going to talk about how to simplify things. Now, if you look at history, essentially, microservices is not really a new thing. There isn't essentially nothing new about it. It's a more evolution of one and the same thing, which I basically started with Corba or even before that. But I guess my knowledge is too limited and regarding what happened actually before Corba. I'm pretty sure that already, or before Corba even, that existed. So need to be very much aware of the fact that in essence, a microservice is nothing more than an evolution of an existing thing which has been happening for quite a few years. And the difference between Corba and SOA is that technology changed, and so it became much, and also integration patterns gradually started to be introduced, and we started to learn how to do more complex data interaction between services and stuff. And so what went wrong in SOA world is the vendors. So they kind of hooked up on the SOA thing, and then they started to hijack basically the whole thing by introducing a huge amount of tooling and stuff and plumbing and ESBs and BPMs, engines and I don't know what. And so that went horribly wrong. And so partially because of that, people started to move on and they started to go to the microservices. And suddenly the microservices is a new thing on a block. But essentially, if you look at the microservices, it isn't really much different, except that we try to get rid of all this technical plumbing and all this stuff in between, this centralized stuff. So you decentralize the responsibility towards the services that interact with each other. But the essence is still the same, and I will explain why this essence is still the same. And but one thing to notice in the microservices world, that we in the meantime start to go basically in the same direction as we used to have with SOA, which is this kind of a stuff like API gateways, okay, and all, typical standard services such as logging or such as things like authorization, authentication, and this kind of stuff is being now solved. And ironically, and especially integration patterns, so how the services interact with each other, is now being basically reinvented. The same thing is being reinvented, what it actually used to be with SOA and in the time of SOA. And Gregor Hope wrote a book, Integration Patterns, more than 15 years ago, and that was completely kind of like in that time everybody struggled with integration and how to do it properly because it was such a mess, and we have learned in the meantime very painful way. And now with microservices we are kind of relearning the thing again, all over again. I noticed this with the many talks, and you can do it. You would definitely advise to do your own research, to check upon many talks on microservices. It's like YouTube is full of it. And I'm really surprised how many of those talks talk about the same problems that we used to have. And a typical one is the versioning. How do you do versioning of microservices? And they solve it in exactly the same way we used to solve it in 10, 15 years ago, basically. So microservices basically SOA without technical crap, okay? So in reality, what you also notice is there is a big discussion between monolith versus microservices. But I think this is a not really good representation of reality, and also reality in the future, because the most of the software is basically something in between in the companies. Almost every larger company doesn't have a single monolith. What they have is a bunch of applications and stuff which interact with each other, and so there is a clear split up of problem spaces. So the question is more how the split up happens and how much. So the microservices talks about that you should split up, really tiny small parts. And in a monolith, you talk about that everything is in one big thing. Neither actually is, I mean, microservices is a very popular thing, but we need to be very careful not to go to this extreme in by far the most cases. So some companies benefit a lot by microservices, but most actually will not benefit by microservices. It's something to be very careful about it. And I'm not the only one who says this. It's basically everybody who's really experienced in this kind of approaches basically says, even the people like Sam Newman, which is the microservices prominent name, and write books about it, really good books, basically explains that most companies shouldn't be doing microservices, something to be very much aware of in the background. So an example of an in-between approach is also CQRS. So there's a whole world, basically 90% of the interesting things happens in between monolith and microservices. And so the microservices I see in the monolith is kind of like the extreme opposites. And while we should be actually much more talking about what's actually in the 99% of the in-between world. And the CQRS is a really, in the meantime, really popular approach. And it's something which is neither a monolith nor a microservice. Okay. And so back to SOA lessons, what we have learned. So we learned that service contracts should have a much more attention than they typically get. So essentially means that we should have much more attention for the customer domain and how you organize the customer domain, how you split things up, and how these parts of subdomains and bounded contexts, basically in domain-driven design terms, interact with each other. How do you organize that? So this is not a technology question. This is basically a design question from a customer point of view. It's not how do you do all kinds of which ASB to introduce, which protocols to use, etc. Unfortunately, that was the mistake in SOA at time, that we are mainly talking about that stuff, while we should be talking about actually how to split things up properly. And another already mentioned experience with the integration patterns proves to be extremely valuable. So if you are engaging with the microservices, make sure that your teams and become very, very familiar with integration patterns, because that's what the exact pain is, and that's what the most difficult part about it is. And then a really important one is the iterative nature of it. So one does not create a bunch of services and designs that and implements that. That's not how it happens. So what you do in SOA, we learned that the hard way, and microservices now people are really learning kind of again, is that what you do is you create first a monolith, and then you gradually start to realize how your domain really looks like, and you start to split things up. Okay, so you never ever want to start with the microservices. And I've seen companies literally making decision, we're going to start with microservices. That doesn't make any sense. Okay, I have a hard time imagining when that would actually ever make a sense. So
maybe,
yeah?
Victor, maybe you could comment a little bit why this is hard to do. I believe that in domain-driven design, it's explained pretty well as being a problem to actually identify the domains in the first place.
Yes, so the knowledge in the beginning of the domains is limited. We have predominantly assumptions, and so you don't know how things are going to evolve, and so the services have an enormous dependency on the actual requirements, what a system should be doing, basically, from a customer point of view. And so since we don't know that much in the beginning, we are working basically with way too many assumptions. So no matter how hard we design in the beginning, the chance of having it wrong is almost 100%. And so once you have it designed it improperly in the beginning, it's quite hard to actually later on start to shift those microservices and reshuffle them and kind of kill them all and then create a better design or something like that. It's really hard to evolve from something very complex into something new, more in the same complexity. It's much easier to evolve from something simple, which is a monolith, and then you start to split things up. So and some things which is remarkable I found nowadays. So many talk about versioning in how do we solve versioning in microservices, but it's a problem that we have solved. And basically, a basic message of versioning of a microservice services is avoid versioning. And so that's yeah, I mean, that's the best solution that you can have. You cannot have always, but you really want to do your best to actually avoid versioning in the first place, because the versions are going to be a mess no matter how much you try, and especially this with the number of microservices, it becomes worse and worse, basically. So another thing, and this is probably the major lesson that we learned, is that kind of an arbitrary number, 99%, but it's kind of a feeling that I have in all those engagements that I have in all those systems, is that the complexity is basically an interaction between microservices, okay? It's in those service contracts and how they interact with each other, and cross-cutting concerns related to that, such as monitoring transactions and etc. So exchanging certain data and mapping the data and so on. So this is actually the real effort, and this is the real thing and the problems that you hear, and it's basically represented in all the talks about microservices and experience reports about microservices. That the problems are rarely about how to implement a single service. It's pretty much always how this interaction across the services happens, what that happens there. So imagine just having a whole bunch of teams, and all those teams are all busy with their own services, but none of the teams is busy actually how the interaction happens between the services. Now, good luck. So what happens is you have two, and this is really important for the rest of the presentation also, you have basically two approaches. So it's really going to be important to understand both of them. One is the shared ownership, meaning that you want the teams to really get much, much deeper and take care and have ownership of the interaction across the services, including the services themselves. So it means that they share the ownership for those services, and or you have a coordination hell essentially. So which means that none of the teams actually own the coordination across the services. So somebody else needs to do it, which is typically some kind of an architecture team or some kind of other part of or combination of with the architects and having a some even departments and groups. So what's really important to understand also is that in the beginning, when you're dealing with the microservices, what you will notice is that in the beginning you have maybe one person or a few people who are kind of looking at these cross-cutting aspects, but slowly what they start to develop is they start to create teams which basically take care of more and more centralized things. So this team becomes bigger and bigger and bigger and bigger until it becomes the major bottleneck in developing anything across actually many microservices. Why do I know this? Because I've been experiencing this for the past 15 years before microservices. It was the problem in SOA. It's simply a consequence of the fact that somebody needs to take care of these cross-cutting aspects. And so you notice also in all the microservices talks is that they continuously talk about we needed to solve this problem, this problem, this problem, this problem. So they never talk about actually teams solving that problem. It's basically somebody outside of the teams who needs to solve the problem. Why? Because teams have a very limited scope of concern. They only take care of the autonomous, independent way of a few services.
Victor,
yeah.
Can we have a kind of like a pit stop here a little bit? We're kind of going too fast. We probably need to mention a little bit on why the microservices architecture even emerged as a need. What problem does it solve? And also there's a question from Bill here. I will just read it for you. That's inherently needed for any substantive change to a system. Those involved need to understand the why. So they don't view it as a methodology, a change adoption, but a fundamental change to their way of business and operations. And thank you, Bill, for your question.
Okay, so I need to.
I think Bill was answering a question in the chat, so that was more of an answer than a question.
Okay.
Yep.
Okay, good. Regarding the Vladimir, regarding the explanation why, what's the benefit, what's the point of microservices? I will get in a second to that. So I'll definitely explain. So essentially, my statement is basically that you either have a shared ownership in teams, which is difficult to achieve. So that's a honest answer. I mean, it's many gave up on that. Many companies, most companies give up on that shared ownership by the teams. Because it's difficult to achieve. It depends on so many systemic aspects of putting organization in place, etc., and that is rather that's quite hard for them. Or you have an ever increasing and more complex coordination outside of the teams, which happens naturally. Basically, you don't have to do anything. It just simply the need to create an ever bigger coordination hell. It just is natural one. Now, in the microservices world, the idea is that that above is the above thing is a false dichotomy, meaning that it's not a matter of a choice between one or the other. So there is a kind of a third one which removes itself from the above dichotomy, basically. So we'll talk about that later on. So if you, typically what we know in large-scale Scrum is if you have a component teams, which is essentially the thing when you have a team responsible for only a bunch of microservices, is you have to have roles on top of that, such as system designer, integration testers, all kinds of business analysts, which are cross-cutting concerns, etc. So you have to have those people. So the reason for having all these roles on top of the teams is because we have a component teams. Okay, and it's a perfectly valid reason to have a many architects, whole architecture departments, etc., and integration testers, because there is a component teams. Once we change from component teams to feature teams, then the need changes also. So you don't need any more system designer, you don't need any more integration testers, etc., etc. Okay, this is quite important to in the context. So Conway's law. So the idea of a Conway's law, and now I'm explaining gradually the reasoning why microservices also, and this is one of the reasons why microservices exist. Is what is very often mentioned, and some of you probably, if you are a bit familiar with microservices world, is that organizations which design system are constrained to produce designs which are copies of the communication structure of these organizations. Okay, so if you have a team which is working on a specific problem, they will also create essentially, and doesn't communicate that much with another team. They will create their own thing, and so the architecture is going to reflect the fact that the communication structure is in a certain way. Okay, the first thing that to notice here is the communication structure is the key aspect of it. Okay, it's not the team's organizational setup; it's the communication structure of the teams. So one doesn't necessarily equals the second one. What is almost never mentioned, and is that further down in the document of a Conway's law, to the extent that an organization is not completely flexible, okay, so the flexibility of a communication structure is the key thing, that organization will stamp out an image of itself in every design it produces, okay? So that's so it's true that the organization, if the communication structure is not flexible, they will stamp out the image of itself in architecture, which is either good or bad. And so it's not that it's the organization must stamp out their own structure in architecture, but it will only happen if the flexibility of communication structure is lacking. So further down, because the design that occurs first is almost never the best possible, and this is the key thing, so the prevailing system concept may need to change. Therefore, flexibility of organization is important to effective design. Ways must be found to reward design managers to keep the organization lean and flexible. Conway's law is extremely popular, but what I notice is that it massively gets interpreted in a very specific way. This way is that that you have to organize the teams according to the wanted architecture, okay? Because of the Conway's law. So if you want to have a certain architecture, you have to have according teams organization. So hence, you first design architecture, and then you say you organize teams in such a way that they can produce such an architecture. This is a big mistake. This is a massive misinterpretation of what the Conway's law is all about. The fact this cannot possibly work in reality. Why? For the very simple fact for what it states in the second part, which is that design, the architecture has to change over time. So this means that you end up with the problem that you have to change organization also over time. So this then some actually stay then, okay, then we change the teams continuously. We are reshuffling the people around and we're changing them every time we change our architecture. But this is even harder than changing the architecture itself. It's a theoretical nonsense. In reality, that's not easy at all. It just doesn't happen. It's a theory which just simply we know it doesn't work like that in reality. Not to mention that you're destroying the asset of having teams and how people work and what they used to work on, etc. So instead of doing that, we need to create a flexible organizational structure, which is then disconnected from the architecture, which is actually working on it. So the communication structure between teams has to be in such a way that they work on, that they can work disconnected from the which architecture is wanted. Meaning if the architecture changes, then a team simply adapt to that without changing the organizational structure. So, so Conway's law, ironically, is the reason why we have feature teams, okay? And so there's a part of a community world which talks about that you have to have a component teams because of the Conway's law. And unless we say because of the Conway's law, we want actually feature teams. It's exactly opposite conclusion. It's really crucial to understand. So in the feature teams concept, each team takes customer-centric item and they then they change the parts of the architecture, whether this is microservices or not, it doesn't matter. It doesn't really matter at all. And they will work on those parts in order to deliver customer-centric feature, so end-to-end. Okay, so they work on a combination of those things. So this means that two teams will work on the same component, okay? And that's okay. So they will share ownership of it. Does it mean that all teams need to be able to work on any components? No, because the teams are specialized from a customer point of view. And if they're specialized from a customer point of view, they will also be somewhat specialized from which components they're going to share or not share between each other. Okay. Now, so when you talk about if you say one team can then take care of many services, aren't we having a problem with the cognitive load of a single team? Is the single team going to be able actually to deal with such amount of information, such amount of services, so much code, etc.? So to understand the cognitive load is this is also argument mentioned in the book Team Topologies, in the meantime quite popular, and but it got it pretty wrong. Is that the cognitive load is related to a single individual being able to do one task at a time. Okay, so it's using a working memory. So if you have a team which need to take care of simultaneously one task at a time, then you also have an issue of a cognitive load. So team can definitely have a cognitive load issue. So they can, at one point in time, they cannot grasp like a million lines of code and a huge problem, and they solve that huge problem. So that's absolutely a problem. But we are talking here about in the feature teams, that feature team one point in time they are solving a quite simple problem, and they're touching a limited number of components, but over time they might touch many components. Okay, but it's over time issue. Now over time is not an issue whatsoever for a team to deal with lots of components. It's just a matter of time. You learn new components, you learn new features, you learn other parts of the domain, and you deal with that. So what we notice in reality in less adoptions is that teams do complain about and they get frustrated by the amount of responsibility they have for the components and features they are dealing with. That happens. But then when we look closely why that happens, we notice that the reasoning is basically crappy code, crappy architecture, crappy tests, and unclear direction, interruptions, time pressure, etc. Okay, so these are the reasons why it happens. But to put it very simply, what I explained here, if you have a crappy code, then as a single developer or a team, you will be able to maybe take care of 10,000 lines of code, okay? But if you have a good tests and good code, etc., you're perfectly able as a single developer to deal with the 1 million lines of code. You can feel ownership for it and do it really properly. Just simply we know that from reality. I've been doing that myself and working with the system with 1 million lines of code, and I have no issue whatsoever to touch any piece of that code or understand what's happening, but as long as it's not crappy, obviously. So now the benefits of the microservices. I explain on purpose in this opposite way because you have to see it in a context what I just explained, the claimed benefits that we have. So the claimed benefit is that each microservice can use different technology. Okay? Now, this is an interesting benefit, and that sometimes is a clear benefit. So if you, in a monolith, you have to use a single technology typically stack. Okay, so if it's built in Java, you're going to need to use Java. And but in the microservices world, you can simply choose per microservices of which technology to use. And that sounds actually, that is an advantage, but it also could be a disadvantage because interchanging responsibility across microservices becomes really hard. And the cost of maintaining this knowledge and building a knowledge of so many technologies is simply very hard. It's not a new issue. one company doesn't necessarily benefit by having 20 different programming languages in their landscape. Okay, so there is the simply logical reason is lacking for that. And so why that happens, that you have so many software programming languages? Because it's cool. So a new developer comes in and says, Ruby is cool, let's do Ruby. Okay, of course it's cool, but why the heck would you have yet another language? Does it really benefit anything? Okay. So replaceability. Essentially, you can replace part in one microservice without replacing the monolith and dealing with the monolith. That's true. That's clearly a benefit. Resilience. So if one microservice goes down, then it does not the whole system goes down. So that could be an advantage. Scaling, ease of deployment. Organizational alignment, I just talked about it. There's actually not an advantage. Okay, so that's something that we think it's an advantage, but in reality, it's very, very likely to be more a nightmare than an advantage. Simply because of the experience of the past so many decades of dealing with SOA, etc. And composability, so that's that you can combine different things together. Okay, so the essential message of microservices world and the benefit of it is that you can decouple. So you have one team A works on one group of microservices and another one with another, and a third one with a third one. Interesting where this comes from, this idea. So the very often stated reference is the Amazon. So almost everybody talks about that Amazon has did this. So they have a 2-pizza team, an idea, and that team is completely autonomous and independent. And Jeff Bezos says to the teams, don't communicate with each other because communication is waste. Okay? And well, what's important to understand, if anybody has worked with AWS and some other Amazon products, is that the products are highly inconsistent. So each team has developed the features in a very inconsistent way with another feature. And so in time, they had to reduce this consistency, increase this consistency. And but they have this luxury in Amazon that they can permit themselves inconsistency of the features and how things work. Because the features are fairly independent. And so every team can develop basically one thing, which is work fairly independently from other one. But that's a trade-off. So Amazon basically made a trade-off by saying each team can go their own way without actually organizing things and coordinating with other teams. But that's not a trade-off with by far the most companies that we are dealing with. You cannot just in one company where you're producing an insurance product in an insurance company say to every team develop your own tiny bit in your own way. And well, there is one customer, they want insurance, and the insurance has to be cohesive, it has to be consistent. Yeah, and so this requires a massive amount of coordination. And so that's something really important to have in mind. And or autonomous driving. Just imagine that each team produces their own part, and at the end the car has to drive. Good luck with that. Yeah. So by far the most cases, having independent teams which they have their own work and they all independently from each other work on a bunch of microservices, it just doesn't make any sense. So it's not going to work like that in reality. And the YouTube is full of talks where they explain the disaster that happens actually if doing that. Okay, so the interesting example, and this concrete is from Jimmy Bogart, and so which talks about a company. If you change just one letter, then you know which company it is. Oh, so search.bell.com. So just change one letter, and then you know which company. So it was a complete microservices disaster, and it's really advisable to watch. And where he talks about an example of having properly separated bounded context, like a catalog, pricing, localization, content. So, and then they needed to search, create a search thing. And so in order to search through these things, it would actually fire up up to 1,000 requests to these things, and to get actually result back from a different parts of domain. So this just simply didn't work performance-wise. And so it took about 10 minutes or something to get result back. So it was just too many steps, etc. So what they did is they basically hacked the whole thing and started to create a database here where these separate domains would push information to the search bell. And he would store that information here, and that information in a local database would searchable, etc., etc., etc. So how this happened, this was basically store procedure calls on a database level and so on. So it was interesting. This was a microservices world and completely destroyed the very idea of microservices, create a big mess, and didn't really solve any problem. And if they would have kept a monolith, it would actually work immediately. We really need to be more familiar with these stories and how the things end up to be really ugly in a microservices world, because you cannot just magically separate things, and if they are not separable. Okay, so I'll stop here and get on with the questions.
Yeah, there's one. And before we get to that, what was the whole idea to split those things? I mean, you say that you cannot just split it just because. You need to have a good reason for that. So what was the reason for in this particular case?
Oh, the reason is because in this case was simply an architect which heard that the microservice is a good thing, and so and things need to be split up because that's good. Seriously,
Okay.
That's what he explains. Yeah.
Okay. So we should avoid that. We should be really deliberate in splitting the monolith to reap advantage that you actually explain on the other page. The other question here is about the additional advantage, and actually I put my comment as well. So Sam is asking, is there any advantage to actually, in a situation when you need to expose API for an external group, is there any advantage to use microservice for that, or you can maybe expose API from a monolith?
Oh, yeah, that's that's exactly then what I meant with one of the slides of extremes, monolith versus microservices. Of course, if you need to have an API, you want to expose API, you just simply expose API. What is exactly that exposes API? Whatever that has actually the capability to expose what is required. And so do we call that monolith or microservices? Reality is usually something in between. So you just simply do that. So just to be clear, I don't have some kind of a fundamental opinion about bad opinion about the microservices. For me, microservices is nothing else than just simply part of a range of a scale of splitting things up when they make sense. So in a certain domain, certain aspects of the domain or a bounded context is so separate from the other parts, and it requires a separate deployability, etc. And it requires providing APIs with a separate set of requirements, quality requirements, scalability, etc., which is not required from the rest. Then you separate things. Okay. So do you want to call that microservices? Sure, it's okay with me, but I don't see the need from it. It's basically the same concept that we have been having for decades.
Yeah.
So I might add just one little clarity piece to that, Vlad. Thanks for representing the question. What I was curious about is if the business goal is to take some service that we've developed internally and monetize it by exposing it to an external group of developers, like the Google Location API, for example, right? So if I wanted to take that one little service we got really good at, making available to other developers internally, and then make that an additional revenue stream as a part of my business goal, is there a different strategy that you might put out in terms of how we look at that approach in terms of the microservices or transformation related to descaling with microservices, Victor?
No, really. I mean, if you put it like that, you want to take a piece of what you have developed and you want to monetize that, you have to probably separate it. and physically, and in order to sell that and provide it, because it probably is probably has a different requirements and utility requirements. So scalability, speed, whatever, security, and so on. Than the other parts. So in that sense, is microservices are perfectly. This is one of the reasons where it does make sense to split something up and monetize, but not before you have those requirements. Not before you actually start. Yeah, don't do it because you think you're gonna monetize it. I see this problem quite often. We plan to monetize it, it never happens, and then you end up with some kind of a complicated mess.
So if we start with that in mind, we say we have this idea and we want to, start pulling that out and charging people for it, but we don't actually have a way of doing that. That's not a good reason to say this is our new microservice, right?
Yes, yeah.
I would recommend that we would just get people off mute and ask a question. One was from Rander. Rander, please go off mute, ask a question, and go back on mute, please.
Sure. I guess my question is, can you elaborate on why the enterprise service bus or significant centralization is bad? And there's been a lot of talk in my company about leveraging Kafka as the primary way for microservices to communicate, keep data in sync. And so hearing a comment like that sort of gets my ears up, and I'm curious what some challenges we might run into.
Yeah. So the challenge is on 2 levels. And one is the fact that if you have something centralized, and if you want a customer feature to be accomplished, so regardless of which service you touch, you always have to go through that centralized part. And that's the actual problem that we talk about. And and especially when it's a synchronous dependency. So it means that it's not something in what happens in the background, but it's actually you have to go through this centralized part. Then you basically have a single point of failure. And so this is a one level of complexity. Now it becomes 10 times, 100 times more complex when you also have a separate group of people responsible for that. So which means that every time you want to deliver something, you first go through the normal teams which develop the feature and services, whatever it is. And then you have a separate group of people. They also need to be involved in order to accomplish connection over a ESB or whatever that might be as a centralized thing. Is it clear?
Yeah, I think so.
Yeah.
All right. And James has a question about tooling related to quasi-monoliths. James?
Yes, Victor. So I buy the overall argument. I'm sold. When I worked at so back when I was a real engineer and actually did real work for a living, slung code. There were environments where we had service-oriented architecture that had, let's say, a dozen services. And those services had nice cohesion. They made sense as a service. And even in a quote monolith, like you say, most monoliths are not really monoliths. They're somewhere in the middle. And there's a variety of services that get deployed. When one says, okay, we want to take the existing code base and we would like to start to build out things like continuous delivery build pipelines and this kind of thing, then in the old days, you'd have to build orchestration scripts that would, take a node out of, you would have to architect it so you could do a hot roll. And then you would have to write some Perl scripts or Python scripts or whatever you were evolved enough to have the ability to use. A lot of this was Perl that I remember, and then later some Python. And you'd take a node out of rotation, you would then upgrade the node, and then the scripting would take the next node out of rotation, put it into rotation, and you'd roll across a cluster. Before you do this stuff, you have to do some database changes, add a column. At the end, you maybe make the column non-nullable or whatever. So there's data store activities before the roll, or in the early parts of the roll. There's database activities at the end of the roll. There's the work of rolling across the cluster. There's work about turning a feature toggle on or off here and there. So there's this whole orchestration, and you have to build all the junk to make that happen in the old days.
Yes.
So if you're taking on, so I've only done a little bit of fussing around with Kubernetes, and the other competitors are similar kind of products. And they have all of this, I remember stuff that we used to spend months writing scripting to be able to do. They seem to just do it out of the box. And it's like, wow. And you give me the little hook that I need, and I just have to write the hook. You know, if I want to hit my database migration tool, well, I implement interface X and I go implement, and it will call it for me. Well, that's a wonderful amount of work to not have to do. So if I'm taking a monolithic system as a software engineer, or as a set of teams, I'm a software engineer, and there is a pre-existing, you know, a dozen clustered services, right? It's a federation of services of a dozen, 2 dozen services. What is the easiest way to work towards, you know, fully automated deployment? Is it better? Do you just pull the microservices toolchain off the shelf? And your microservices aren't microservices, they're big fat services. But hey, you know, at least it's not a VM, and you don't really care if it's a VM or not. You just care that, or I remember we did it on bare metal. You just care that all this plumbing that gives you the deployment roles and all is there, and you go towards it in order to get access to that, not because you necessarily embrace a microservices world. Does it turn out to be more trouble than it's worth? Are you better off you go out to the the people that do Terraform, those guys? Do you go with their kind of tool chain, or do you go with those are not mutually exclusive, or do you stick it in a microservices scheduling orchestrator framework just because you get the cool tools? What's the smart thing to do? You're breaking up, Victor.
I'm not sure why.
Much better now.
Okay, much better now. Okay, so I'm going to sound a bit old-fashioned. After all those years with SOA and stuff, we have been kind of in the beginning. You become really insecure and unsure about your own knowledge and experience, because the vendors are flying around the ears, and they all explaining they're going to make deployment marvelously simple, etc. And then after all those years, I found out that the deployability of a microservice of whatever service or application, well, actually specifically microservices, etc., is incredibly dependent on and mostly dependent on design of those systems, and so that proves to be a way more important problem to solve, and than actually which tooling to use, etc. So the one major challenge, which is nothing new, is that deploying a single microservices and the whole idea that you can deploy it independently microservices is completely dependent on the fact of if the change propagates to other microservices. And quite often it does propagate, which creates a nightmare, and in a microservices world, and it's not an issue in a monolith world.
Oh, that created a nightmare in the old school SOA.
Yeah. Yes.
If you couldn't
correct.
deploy individually,
Yes.
I remember we had a company where
yes,
we had
it doesn't matter which tooling you use.
Yeah. We only
it doesn't really
one per
matter.
night.
Yeah. So it really just becomes a nightmare. And so there are literally talks from many companies which talk about this deployability nightmare. The original idea was actually that you can deploy separately, and they ended up actually deploying everything all together all the time. And so every time a single service change, you need to change all the services at the same time, because that's the easiest way to kind of make sure that things don't break. And so regarding the tooling, which tooling to use, etc., I don't really have an answer to that. Yeah.
When I
Don't-
said tooling, I
yeah.
wasn't talking about brand X of microservices or brand Y. My presumption would be you would pick something open source. It was
Yeah.
more of a, will life be easier if you go down, if you pick up the microservices tool chaining?
Yeah.
Or will life be easier if you pick up the old school way? Well, I mean, old school can be many old. I mean, I've done stuff where you do kickstart scripts, right?
Yeah.
It's
so-
not bare metal.
So,
Yeah.
Victor, could you give an answer enough for James to go and research this, so we can actually?
Yeah, I'm
No.
fine
Go
moving
to the
on.
next one. Okay, yeah. So no, I don't have a really, I mean, a more generic answer I have. Is that writing scripts nowadays is not a good idea. So lots of stuff is standardized, and so the tooling is that sense is really useful. But more than that, I can't really give. So it depends enormously on what let's say. Okay, next question.
Yeah, thank you. A little time check, Victor. How much more time do you have? And are we good?
Continue.
We good?
I'm
Okay.
good.
So we have one question from Simar. And Simar, if you could go mute and ask a question.
Sure, thank you. So one of the problems that we run into is we are microservices-based architecture, but our services are used across multiple products. So we are struggling with the best testing strategy because we are always concerned that one change that we make can break all other products. So we are constantly running regression tests across all products because of any change we make. And that's very difficult for us to sustain and maintain. So we're wondering, are there any best practices around this?
Yes. What you already do is unfortunately at a certain point inevitable. So you're delivering for the customer something end to end, and that end to end requires a usage of some kind of a shared services. And so if you have multiple features or multiple products, it doesn't matter how we call them. And they use this shared aspect, and you will have to test end to end from those multiple products in regression way. So if you do it automated, which you should be doing in any case, then it becomes cheaper and cheaper and cheaper to do that. That's called end-to-end testing. So it's acceptance testing, and so this remains to be the gold standard basically for testing. And so alternative to this. And so the first one shouldn't be forgotten. You cannot just kind of avoid doing that. And why? Because the risk is too great. So alternative to this is that you on top of it also do a much faster testing, which means that if you develop a service, it has such a good contract that the contract is comprehensive enough and is also tested itself that if you change, that you are aware of that you whether you have changed the contract or not. But it depends, and that's why I mentioned the service contract so much about ESB, so about the SOA world, is that how good your contract is will influence how much reliability do you have when you test only the service and you find out that the contract is not broken, and then you just simply go into production, and then you know that whoever uses the service is not going to be broken. The fact is that you only can go so far, and the contracts are never going to be perfect, so you are still stuck with the fact that you need to do end-to-end testing. So your only option forward is basically to automate it. So the more you automate your test, the better it is.
Thank you. And follow up to that from organizational structure. Another thing, so we've been thinking along these lines, but then another roadblock that we hit is, so let's say if we have certain teams who are working in certain products, but now they made a change. So the end-to-end testing that needs to be done, who's responsible for that end-to-end testing, right? Is it organizational design is what I'm asking over here. And we've tried a few different ways, but it's always a struggle. So are there best patterns around this?
Yeah, this is a very common manifestation of component team problems. Essentially, what I talked about is the feature teams versus component teams. Feature teams don't have that problem simply. So this means that in reality, the first team that picks up an item and that requires a change in that shared component is also responsible to make sure that nothing is broken for all other things.
But then right. So then you're running into this team needs to understand the whole ecosystem and all the products, right? So that's a lot.
Yeah, not necessarily, because if you have a really comprehensive testing automation and all they need to do is make sure that the tests are running and green. And so if some test breaks, then they would go dig into that, and they might be unfamiliar why it breaks or what happened, etc. And they might need to talk to some other people in other teams and require help. And we call those people component mentors or experts or whatever, and they assist with that. Yeah.
Okay, thank you.
You're welcome.
Great questions. We probably should move on, and we can ask other questions later. And would you like to share again, Victor?
Sorry, share again?
Is it all your slides that you wanted to present today?
Yeah, I mean they have many more, but they also. Do you have more questions also?
Okay, so we have one follow-up question here from Randar. Randar, would you like to?
Yeah, and I think it's fairly brief. You just, at the beginning, you sort of said avoid versioning, and then there's been a lot of conversations around deploying a number of microservices all at the same time. And sort of we're trying to figure out how to break down the monolith. And, you know, we know that the features are going to evolve in different ways in different times. And at some point, somebody's going to try to turn it into a string or vice versa. And I'm just sort of, if you sort of said avoid versioning, then what are the better alternatives?
Yeah. One thing in a service design, which is often overlooked and in fact mistakenly advised exactly opposite, is that the one has to design contract really well before implementing the service, so that you need to design the interface really well before implementing the service. I advise exactly opposite. So do not spend time on your service interface in the beginning. So what is the result of that is that you do absolute minimum of a service interface. So imagine that you have a REST API, and this REST API has provides information to a consumer, and it's something on, let's say, insurer. It's a person who was insurer in an insurance company, and so it has a whole bunch of information. And the first consumer says, I just need a first name and last name. Instead of thinking very thoroughly what kind of information should be provided, because there might be more consumers, all you do is you provide a first name and last name. Okay, so the next one comes and says, oh, but I also need the full name. Okay, what you do is you add a full name. You don't need to create a new version. You just add a full name. This means that you don't need to create a new version because the previous one is not going to break because you didn't change the existing fields. So starting really simple and small has a huge benefit into avoiding the versioning, basically. So the chance of
but I guess what if it's an actual breaking change? Like, let's say you're switching something from, oh, I don't know, like a GUID to a string or something that will actually break the other side. Like, it's not an additive property, but an actual change. Like, is there any alternative to versioning in that case?
Yeah, so this means that there's something substantial about the service has changed, that you're essentially creating a new service. That's how I approach it. So I wouldn't then create a new version of the service, but I would just simply create a new service. And then you have simply variations of the service. And some services become deprecated over time. But it's not a versions of a service. It's basically just simply, just like in the code we have with the libraries. The concept is not really new. So in the libraries, in coding, some stuff becomes deprecated over time.
So it's maybe comparable to the database incremental changes when we don't delete the columns, we add new columns essentially, and database still a database. So this is how we avoid the inconsistency with the versions of software. related to
Yeah,
database. Okay.
because if you do versions, you're basically in the thinking and design, you kind of disconnecting the fact there is a there is a certain need in time that has been there and still valid for many of the consumers, and then over time there is a new need. And by introducing just a version number, you're basically losing the information about what is exactly difference in the need. But if you create a simply new version, and over time you might make this one deprecated, then you value the fact that over time there is a different need also for these services. So you are continuously also architecting those services in time aspect, and not only as if it is a kind of like a snapshot, which the only last one is the relevant one, and where you kind of continuously pushing all the old ones to the new one, and ignoring the fact that the old ones actually really depend on the old one and don't really like the new one, maybe for whatever reason. Yeah. So this to give you something to ponder on. Yeah.
And there's another question from Jerry. Jerry, please.
Hey, Victor.
Hi.
So let's say we're really proud of our microservices right now, and then we jump on this call with you and we hear this, and now we're scratching our head going, is this the best thing for us? Is this the right thing to do? What advice do you give folks that are really proud of their microservices, but they now have built this awareness that maybe there's an alternative that we should consider? What next steps might you advise folks to do?
Okay, so you already have microservices, and but then I assume there is also a problem, and so they are thinking like there is a next step and something better or whatever. But I would first think there is a problem in between. If there is no problem, then
well, yeah, there's definitely opportunity to improve. We've gotten some of the benefits out of microservices, but we realize that we still have these layers. It's still not, we still want to continue our maturity journey, and not everything is microservices, just some things. So
yeah,
now we're going to leave this call. And we're going to go back and we're going to try and have a conversation with other people about, oh my gosh, we've had this conversation about microservices. So what advice might you give some of those folks?
I guess the number one is which problem did we try to actually solve with the microservices? Have we solved that? And now we have this situation. How is that situation going to develop over time? So systems thinking, essentially. So I would do system modeling exercise on this thing, and kind of like a thing. We see basically already some development happening, and one thing which I learned in all these years with dealing with architecture is that disaster issues regarding architecture happen only over many years. So the mistake happens right now and will manifest itself over 5 or 10 years, especially in the larger companies. And so when it manifests itself, everybody forgot it's actually for a big part caused by the original idea, which at that time looked really good. Now 10 years later, it proved to be actually a disaster. So how do you discover it is going to be disaster or not, and that something should be really dealt with, is that you try to do system modeling. For example, if you have many microservices, we see that we have a growing need for all kinds of a centralized stuff. So how is that going to develop over time? And and if you hopefully conclude, then that the centralization of all kinds of stuff is a really bad idea, because we know this from experience and in architecture, then what kind of alternatives do we have to decentralize, etc.? And another one is really avoid ownership per team. And so if you don't have ownership per team, but you have a shared ownership, so feature teams, you get basically for free retrospective of what is happening, and you get for free the visibility of the pain. So if a feature team needs to deliver something and they need to deliver end to end, they need to cross-cut many services, they will or will not. They will notice if the pain of it, and they will notice that something is really off, and they will notice that, for example, if I need to implement a feature, I'm too scared to touch another service. Why is that? Because when I open up the service, this other team has developed something horrible, and so then you start to discuss that and you start to question. So is this really a good idea? Another thing which is really weird to me is that people reduce valuing the quality of the code. And the reason in a microservices they do that, they think like, who cares about the quality of the code? Because the service should be easily to replace. So why should I spend time actually making quality code? Because I can replace it in a matter of a few months or something, or a few weeks. And that's such a misplaced idea. But it gets manifested over time. Yeah. Another thing is that who cares basically over the whole overall view of all the microservices and how it all looks like? How does it gonna develop over time? Okay, is it just gonna kind of organically grow into what exactly? So I mean, you can organically grow cancer. So do you want to organically grow cancer, or do you want to organically grow something which is useful? This is a really important question.
Thank you very much, Victor. Thank you.
Yeah, thank you, Victor. I guess it is kind of like a related thing. Since we talked about the benefits of microservices, talk about why people do microservices. What is the cost of microservices? Why would you really take time to think about whether you take one route or another?
Well, the cost of a microservice is huge, and basically everybody in the microservices world also acknowledging that. And hence that the main names such as Sam Newman say it's not often that that you should be actually doing microservices. And so the factor to decide whether it even makes sense is simply amount of decoupling that you have in your domain. And and the cost of a microservices is integration. It's just simply way more difficult. It's in the monitoring, it's in things like versioning, it's in refactoring, reusability of the code. Refactoring is actually a really interesting one, because refactoring across microservices is practically impossible. And refactoring a monolith is nowadays completely established. So I can perfectly and something that, by the way, Facebook and Google and Microsoft are valuing extremely is ability to refactor massive amounts of code in one time. So Windows, for example, is a single repository development, and they find it extremely important to be able to refactor a massive amount of code in just like that, and with the tooling, and they do that continuously. And so that's something that you can't really do in the microservices world. To give you a bit of a, not sure if I'm answering the question. Yeah.
Thank you. And the next question from David Nielsen about the component vendors.
So yeah, well, actually, I kind of changed my question a little bit, but this is around tech debt and moving towards shared ownership of microservices, like kind of an intersection between there. Is there any benefits of, like, or how do you manage tech debt with that type of an organization if you have different feature teams working on many microservices, and maybe there's a product or architectural decision that impacts many microservices? Is it that feature team that is responsible for any tech debt for many of the decisions made, or is it more efficient for that type of an organization to control tech debt over a componentized team organization? Have you seen any wins or there, I guess?
Yeah. Yes, short answer. Feature teams are simply way better capable of dealing with the tech debt than component teams. So what I see in the reality is that the teams which are dealing with their own components, they obviously take care of their component, but they take care of the component within their mind of how they feel this component works and does, etc. And so this means that there is a limited ability to question your own stuff. So especially if you're really familiar with the code and it's very small, if it's complete crap, you're still able to actually deal with it because you're only dealing with that part. Making it ever more impossible for other teams to deal with the code. So the incentive to deal with the technical debt is just lower. Quite often they don't even feel there is a technical debt. But way more important aspect of technical debt is that technical debt of having a completely unneeded component. So to get rid of the service or get rid of the component. So that becomes only visible if the ownership is across many components. But if I own my own component, I'm never going to say my component is not needed or services. So and the way I did it is completely wasteful, basically. It can be completely removed. So if you have a feature team, it's just simply more likely that to happen. So incentive to do that is much, much higher. And yes, there is more to it, but this is the key thing. So the perspective is so broad for a feature team, they are more likely to actually see the technical depth and also deal with that.
Thank you.
Thank you. And the next question from Sumaya. Sorry if I pronounce the wrong way. I have a question about microservices deployment. Please unmute, ask your question.
Sumya, you're off mute, but we can't hear you. Maybe select your microphone input.
Yeah, it's actually a pretty good question. Oh, okay.
Yeah, I unmuted myself. Thank you. You got my name right, Vlad. It's Soumya. So I have a question about microservices deployment. We currently deploy about 30 microservices at a time, which takes a long time to deploy. We are thinking about how to break it down. We have a short-term solution and short-term improvement options, but long-term we were considering to move to independent service deployment where we can build the gold standard that I have read around with few researchers, YouTube video, etc., is to be able to get to independent service deployment where you check in code to one service and all your automated test suites run and it's ready to be deployed to prod. Is that the right way to think, or should we consider thinking of bundled service deployment, say per product, not necessarily whole platform?
Well, the way you describe it is so far you kind of missed the whole point of having services even. So by inability to deploy it separately. And so you have basically 30 services and deploying all together. It's kind of missing the whole point of it, because the whole point of having the separate services is that you can deploy them separately. And so nevertheless, what you explain is a very common thing that I see very, very often. And but let's put that this way: if you do not achieve ability to deploy separately, then the whole point of services is kind of gone. And yeah, you basically have one big waste. You should have a monolith and instead of 30 services.
Yes, that's what we hear. So but we are trying to see which is better, whether it should be, we should still try to target deploying a single service at a time then.
Yeah, alternatives. I mean, it seems like it's so obvious. You should just simply deploy separately. But it's in reality, depending on the domain that you're working in, much harder than it seems. There is a reason why you probably need to deploy all of them at the same time. And so it could be something to consider, that you actually cannot deploy them separately, and that you probably that you might need to actually deploy them to go back to the monolith partially or completely. There are cases which have done that. Yeah.
So Victor, is it the case when you actually need to go and look back into domains and consider what domains you have? So is it a sign of a bad domain split so to speak?
That could be. Yeah, that could be. But I mean, that's another option, that in the data simply the way the services are split are not split properly, which forces you to do deployment all the time. And how come is you didn't split properly, so you have too much coupling between services. So every change in one propagates to another one, and that's why you actually need to deploy all together. So that's right, Vladimir. The thing is that quite often you can wish loose coupling, but the domain has to permit it. So some things just require simply high level of integration. So which means no matter how much you want it, lots of changes will propagate to another service. It just depends on the domain that you work with.
Yeah,
How about
that's kind of, sorry, go ahead.
Go ahead.
It's going to say that's kind of where we are. Testing is a major blocker for us. We need to, I think that's the question Simon brought up. We work together, but
Yeah.
the end-to-end testing, that's a big blocker for us. We end up testing everything together, and then we end up deciding we have to now deploy everything together.
Yeah, it's yeah, exactly. So one of the reasons I gave the talk, basically, it's kind of interesting to observe. This is a very common problem. I wouldn't feel bad about it. It's simply a consequence of microservices is not a good thing per definition. It's a good thing in certain cases, most often not. So that's something to consider. Yeah.
Thank you. Thank you very much. And the next question from Nadine. Nadine, could you please ask your question?
Yes, hi. So my question is shared ownership. Can you talk a little bit more about what that actually means and how does that work practically? Because often when there's multiple owners, there's often no owner because, well, it's not mine, it's yours. So can you talk a little bit more about that, please?
Yeah. So the ownership of the services is something else than a responsibility. So when you say when it's a multiple owners, there is no owner. I guess you mean probably when there is a everybody responsible, nobody's responsible. So I separate the two. Shared ownership means that a team is able to own the change so that they're required to make. So they're already responsible for the change because it simply is required by the feature that they need to implement. And so they're going to touch the code and they need to do this. And so they will implement this change and they fully own implementation of the change. Okay, so now it comes to responsibility. So I guess you mean if you is this team gonna feel responsible for the quality of the code that happens there? So in reality, it's quite often an issue. Not all teams gonna be feeling equally responsible. So what you have then in less is a component mentors. So which are people feeling more responsible for the quality of one component than others. And so they will then teach and mentor other teams, or the other teams will ask for help or might ask for review, etc. And so this is the dynamic. So in a less, it's not the case that everybody is responsible for everything. No, there is at one point in time always very clear who exactly is responsible for every single thing. So that's something that seems with the feature teams seems like everybody is responsible for everything, but that's not the case. Like for example, if you have an issue, there is a single person which will pick up the phone when a user calls and says we have an issue, and that single person is responsible to make sure that the issue is resolved. It might not be the person gonna do it, but is responsible to actually make sure that it happens.
And so how does that work? So if my team changes code in a service that was created by someone else and adds a feature or adds just some small function, how does that practically work? Especially with microservices, when we talk about you build it, you monitor it, you run it, you own it. We're not microservice. We're not giving it to somebody else to operate. There's a team that owns it. Is it that basically if a non-owning or non-owning team makes a change, it gets reviewed by the owning team. There's sort of gates, I guess, or like a gated check-in process where the necessary code reviews happen. Is that the idea?
So you have to first to imagine two different organizational contexts. The organizational context that I talk about when I have a feature teams, you don't have this notion of it's mine and leave it to me, and so that notion doesn't actually exist. So people have architectural communities, they have component communities, and across many teams they talk to each other how to deal with a specific component, specific questions, etc. So that's the context where I talk about. And so in that context, there is a component mentor which advises, but basically everybody can change anything, etc. The context that you talk about is where you have a very strong ownership and the culture of that. Then you don't switch just like that to the context that I talk about. It's much, much harder. So what you typically do, you start to lower the blockade. For example, you don't want to have you want to get rid of the gatekeeper review stuff. So first you want to be able to permit other teams to make changes, okay? It might be that you have still a gatekeeper, so somebody make a change, but it has to be actually checked before it goes into the master or whatever. And then the next step could be that you say, you know what, we have a component mentors, people who advise others actually how to do that, or at the same time. And then at some point you remove the gatekeeper thing, and it becomes actually pull instead of a push thing. Means that the team which makes the change says, I need somebody to review it before it goes into production. But it's not a gatekeeper thing. It's a more kind of like a responsibilities flipped around. And so people start to feel more responsible for the fact, etc., etc. So this is kind of like a steps. The really big step, then it goes into the context that I talked about, which is the feature team, is that you restructure the teams, which typically means that the people who are together and component team are restructured into feature teams, which massively shifts the mindset and the setting within which people start to take responsibility for a broader thing. But the knowledge is obviously still there. So the component team experts are still around. They're going to help the teams and others. So the big assumption is that if you have everybody change everything, that everybody is going to go crazy, okay? So you need to have police agents. Without police, everybody's going to go crazy. And so that's simply not true. In reality, it's quite opposite. People are afraid to touch things.
Victor, actually, I like how you approach this question from the customer-centric perspective, that the teams actually own the product, not the parts of it. And I don't know if you want to go, segue that route. I will leave it up to you. I just want to mention that you delivered other speeches on similar topics, and maybe we can provide some of the URLs here. I remember you've done one on the New York LESS meetup with Gene, and there are many great examples about the dirty hacks and nasty hacks, and going back to monolith even. So it was pretty spectacular.
Good. Let's see.
And there's another question. I'm wondering if that was answered already. How do we drive accountability with shared ownership? I guess we talked quite extensively about this, but I don't know if you want to add anything, Victor.
Do you want to come off mute, Samir?
Yes.
Question was, thanks.
Nice. And the accountability, and it's the word which actually, I don't know if you know, but in many languages doesn't even exist. And it's the whole meaning of it has a different meanings. And so in accountability word, and it's difficult to translate in many languages. And if it gets translated like in Chinese, it means somebody to punish in retrospect. So later on, to have somebody to punish in later on, and that's basically the definition of it. And so, and then others say it's basically same as responsibility. So let me take it as if it is more or less the same as responsibility, which is not really appropriate. It's not the same thing, but you want to make sure that the people actually take care of the stuff and they feel accountable for it, and so they feel responsible for it. And that is essentially then connected to the fact that there is always a specific group of people with a specific assignment or a specific individual which has responsibility. So, for example, if you have an issue with a component, there is in reality always a small group of people or a community, for example, which feels responsible for it. So if that group, because it's a group, doesn't take responsibility, there is a facilitator of that group. And so a community facilitator, which is typically an expert in that component or whatever, will feel responsible for it, but in a very facilitated way. So which means that this person is going to say, this component is being messed up, guys. We need to talk about it. How come there is a mess? What are we going to do about it? And because we must do something about it. And the key thing is that you provide the means to exercise this responsibility. What goes wrong in organization is not necessarily that people take responsibility, but it's the fact that they don't have the means to take responsibility. So the means are literally being taken away from them. So if the team doesn't feel accountable or responsible for something, it's simply because there is somebody outside which is actually responsible for something. And so people start to point, yeah, why do we talk about this? Because he's going to decide or she's going to decide anyway. And so this is how I this is how it then looks in reality, that the means to feel responsible for something is way more important than having a specific individual which you can cut the head off if he doesn't do it properly.
Thank you. Yeah, it was more for responsibility and production monitoring, and if an event takes place, who's going to help out? So
in production.
Yeah. So if there is an issue,
good question.
Who helps at that point?
Very common practice for that is a rotating team, a rotating operations team. So if you have, let's say, 10 teams or whatever, one team is going to take responsibility for one sprint to take care of production. And so they use the maybe full sprint to do that if there is lots of production issues. And it's a very common practice. And and there is one person which has the phone next to them, for example, or an email access, and so in that team, and it's going to be dispatcher. So these are practical things which people do, and teams do. And so there is one person who's dispatcher, and a team becomes also partial dispatcher. So they pick up the urgent stuff, but they usually analyze first and they see who actually caused the issue. They would then dispatch that issue to that team.
Thank you.
Yeah, it's very, very interesting that it has parallels with the commercial aviation. The fact is that the pilots never get the plane that they know. They always get a random plane, and they need to do all the checks. And it makes them uncomfortable, maybe, but it actually improves the quality. So very, very good question. Cool. And the other one is again from Randar about a related question to that. So maybe Randar, you can.
There's actually been a lot of people who've sort of touched on this already, but this is a fairly less specific question. But one of the concepts in LESS is really that you have a number of similar teams that can take any stories off the backlog, which works well from a development point of view. But nothing I've really seen in LESS sort of talks about the operational side. And I think people have talked about, well, what about production bugs? And if my sort of thought is, if teams were assigned areas that they own, it'd make the process simpler when they're triaging bugs or when enhancements come down. It feels like it'd be more efficient to have teams sort of own areas, and then they can also, see what technical debt there is, and then use something like the Sprint Planning 1 to assign new features, but teams sort of continue to own existing features. I'm sort of curious your thoughts on it.
Yeah, so the reality of a LESS adoption is if you have, let's say, 20 teams, is that you, despite those teams are going to be somewhat specialized from a customer point of view. If they are somewhat specialized from a customer point of view, this will reflect in the architecture also. So this means that the teams have some sharing of the services and components they do, but the overlap is not so large. So this means that the teams will there will be 2-3 teams which clearly feel responsible for a specific components, simply because they mostly touch those components, and other teams rarely, if ever, touch those components. And so this makes it already easier, because then you have like 2-3 teams which are feeling responsible for that. And so this is one aspect that is really important, because to avoid the thinking and assumption sometimes that all teams are responsible for all components. It's in reality, it's not really like that. They're having the same ownership, shared ownership, but the responsibility is quite limited to the number of teams out of practicality and how it just happens naturally. Now, production bugs operations. I guess I explained already how it works with the rotating operations team. But if you that means that if you rotate across 20 teams, that one team is going to be responsible for operations of everything that happens there. Well, in reality, they are more a dispatcher, and so they're going to dispatch to the teams. To the team which actually caused the issue. This also stimulates a lot the sense of ownership, and that you don't mess things up. And so this is a really important feedback loop, which we are very familiar with from a DevOps world and DevOps idea. And this is essentially means DevOps, actually. And now the thing about if you have one team. So instead of in a microservices world, they said single team is responsible, and they feel really kind of responsible for doing refactoring, etc., etc., etc. So in the feature teams, this is not entirely gone. It's instead of one team, it becomes actually 2-3 teams, and in reality, it's not really the whole teams. In reality, it's a few developers in a team which are more senior, and they get together with a few developers of other teams occasionally, and they talk about this component and how to make it better, etc. So in feature teams is not the opposite of a single ownership thing. It's simply we make it more fluid, and so there is no limitations. We don't put boundaries around teams, but it doesn't mean that everybody is then responsible for everything, and everybody needs to take care of everything, and everybody feels responsible for everything. So it's just simply more fluid, and especially important to talk about the reality. In reality is that you have a few senior developers in one team, few senior developers in another team, few senior another team, which talk to each other about how to improve some code quality in one component, that they should be doing refactoring, and then they organize this work, and they have this multi-team sprint planning too, where they discuss with each other design of it, and then they spread this work and decide who's going to actually do the refactoring in which way, etc. Does it help?
It does. Yeah, thank you.
Yeah.
Not to forget, there was a question from Dr. Kim Patterson at the very beginning, and I don't want to forget this question. So could you please come online and ask a question?
Yeah, can you hear me?
Yes.
Okay, yeah, just this is actually a scaling question, not really a current topic question, just scaling with less. How do you deal with it when you're scaling to a Scrum environment and using a less scaling solution when you really don't have management on board? In other words, management goes along with it, but we're trying to descale a little bit, trying to get things down to a product team environment. And we have, unfortunately, have tons of component teams, but that's beside the point. But the issue is that the management kind of goes along with it, but they're really in charge. You don't have self-managed teams per se. Management's in charge. How do you deal with that? I mean, Les says just structure it better, but when you don't have management understanding the why, how do you deal with that? And again, my solution is kind of rhetorical. My solution was train the managers, get them to be more agile, management savvy, and provide them some training, and get them on board and try to train them a little bit. But again, management's in charge. They're allowing things to happen, but they're overstepping their boundaries. We don't have self-managed teams. We have managers that's kind of taken over the teams a little bit. It's not working, of course, but what would you do within this scenario? Would you use like a Rockman concept to get more management trained on Agile, or what would you guys do?
Yeah. So the kind of a more or less standard way of not really standard. So the typical way of less adoption, how it happened is, and one of the key principles in less adoptions is top down and bottom up. So top down means that you have a high enough management buy-in and involvement before actually doing anything, because it's the management essentially which drives the change, and they take the ownership for it, and so the change is not even driven from sideways or something like that. So this means that management quite high up needs to be trained in lean thinking, systems thinking, organizational tools. And so I explicitly state these three, and I don't state agile, and I don't state less. And because it's quite important in today's world where the aversion against the frameworks due to SAFe has become really, really high. And so that's why I notice this now more and more, that in companies, they when you say less, they start to immediately imagine like or agile, and it feels almost demeaning when you say to management, you need to be trained in agile, and agile has been around for ages, and they quite often feel they're already familiar with it. It feels almost like you're insulting them. So instead, I say we need to really go deep into the organizational tools, how to organize complex product development with many teams, and this requires lean and systems thinking, and they are more receptive to this, and not all the time. And so it starts usually with a simple conversation at really high up in organization, essentially as high as it as high up as that you get to the level which has any influence on organizational structure. So this could be very high. In the case of, for example, Société Générale, where I was involved 4 years, it was the very top in Paris, and there was some kind of I think 6-7 levels in between. So they needed to be involved, and I get to know them personally, and yeah, that's how it goes. And then and this, why this needs to go so high up is because when you start to talk about the fundamental idea, such as simplification organization, this is pretty heavy stuff, and they immediately understand what it means, and they usually agree that it needs to be done anyway. And so this is where the less than gets accepted. That management already knows basically that organization has spiraled into complexity, nightmare. So the only solution is to simplify it, and you provide a way of thinking about it, and so you teach them how to think about it, and dynamics and systems thinking about it. So this then becomes really powerful, and so definitely don't sell less, or don't sell some kind of a framework or whatever, and so this tends to work really well. Yeah.
Thank you so much. Okay, got it.
Thank you, Victor. There are a couple more questions. The next one is about using microservices for logging and tracing from Ravi. Maybe Ravi, could you please ask a question?
Hi, thanks, Vladimir. This is Ravi. So we don't have tracing or distributed logging right now. We just use the Kibana to debug. Sometimes it's really difficult when we are testing, especially when you're doing the performance testing. So we can't deal with that. So, and then we don't have a luxury to start ground up because we are in the middle of migrating from monolith to microservices. And then, as Soumya mentioned, we have 30 microservices in production. So what is the best way or the best practices? Like, we have other open sources, distributed logging, tracing, but how can I adapt the one that works for me, which is already my microservices running in production? So how can I deal with it? Like, is there any, what do you call them, tooling, or like best practices, or like any other options that I can adapt in my organization?
Yeah, so somebody mentioned Splunk already. There are quite a few others also. So I keep avoiding talking about the tooling because like a logging is another really good example where I notice in reality is the design of logging and is the actually issue and lack of a design of logging. So every microservice does it in own way logging. And in reality, what you need is highly standardized logging across many microservices. So the more standardized it is, it better it becomes to deal with it. So this means that you have some kind of agreements and the teams agree with each other and continuously improve standardization of the logging. So typical mistake is to log as much as possible, which proves to be actually exactly counterproductive in figuring out what is really going on. So so you want to, you would, in the case of feature teams, you would organize, or component teams for that matter, doesn't really matter, is that you organize a community and a logging community, and they talk to each other and regularly come together and talk about how to improve logging across many microservices, how to actually get that to better and better. I noticed that it's a never-ending game. It's not like you do it once and you are finished with it. It has to be continuously improved. And so standardization is the key thing. So standardize and the standardize on many levels, such as, for example, the categorization of the logging messages. What information do you put in? What type of logging do you actually do? The amount of logging that you do, as I just mentioned, is really important. Usually it's that you need the less logging instead of more logging. And yeah, I don't know if that helps. So tooling, yeah, I mean, so this is a kind of a general best practice. Tooling is really, yeah, I don't think it's, I would say anything which is that much useful. Yeah.
Yep. Thank you, Victor.
Yeah, indeed. Another point of research would be just to research different tools and what solutions they recommend, because there are multiple solutions in the market. And you can check out different DevOps conferences. Actually, DevOps conferences, you know, and professionals there like talking about different observability tools and login tools there. So you can get a wealth of information from there. And the time check, do we have much more time? There are a couple more questions, but 5 minutes?
5 minutes, yeah.
Oh, okay, sounds good. So the next one is about the product, and that was the question from Satish. So please, what's your question?
Sure. Thanks. It's just if we are organizing feature teams to work on features from a whole product point of view, what do we mean by a product in this particular context, especially in the case where we are not a digital organization?
What kind of organization?
Let us say BMW. We are not a BMW, any of the car manufacturers are not a digital organization, but obviously we have a digital team. So what's the product there? It's not something that our customers actually buy.
Oh, okay, so let me use an example. Insurance company, health insurance, and that's not they are not selling the software product, and they have a single product, and it's called insurance, health insurance. Yeah, a bank provides financial services. That's the product. Telecom provides maybe few things like communication services. Nowadays they combine with the TV and the streaming and stuff, and then maybe a third one. Okay, communication services is basically internet and this kind of stuff. So there are maybe 2-3 products. Yeah. Apple has maybe 5 products. Amazon is very unusual. Maybe it has 10 products. So this is the context of a product. It's a very, very broad. It's from a customer point of view, what the customer sees as a product. And also not only customer, is also if you have a lots of sharing between so-called products, it's very likely to be the single product. And so this is to give you a bit of idea of what the product, what we mean by product. Yeah. Does it help?
Yes, that's quite helpful. So product from a customer perspective.
Yes. So it's very broad, very wide. Yeah.
Thank you.
Yeah.
Thank you. And then next is from Stephanie about some situation that may happen in the team. So Stephanie?
Hi. My question was, you touched a little bit about each component or each feature having like an expert that has a lot of knowledge in that domain. How do you maintain that knowledge, since unfortunately people leave companies and that knowledge might be lost?
Your audio is messing up again. There you go. And you fixed it.
Is it better?
I don't know what you're doing.
Okay. No idea what the problem was. So in the feature teams, it's not the case that every team has the necessary expertise in a team to deliver. It's simply practically impossible to achieve. So let's say you have one component and 2-3 people are working on that component, but you actually have 20 teams, and so you're not going to spread 3 teams over 20 teams. Okay, 3 people over 20 teams. So, but the other teams need to work on that component too, so they will have to learn. Meaning that the feature team concept automatically ensures learning. In fact, it's an absolute dependency on it. So feature teams only works if learning organization culture is established. So there's a massive amount of learning happening. And so if somebody leaves, you are more likely to not end up in a problem in the case of a feature teams, simply because learning has been happening for quite some time. So it's usually a problem in component teams, and that you have a limited number of people, and those people expert in one component leaves, and then you're suddenly stuck, especially with dealing with the stuff like a COBOL, etc. I've seen nightmares regarding that. Companies stuck with a huge disaster because the person they depend on a single individual, and with a quite toxic culture sometimes. But in feature teams, you have that problem less, and especially over time, because the other teams have to be able to deal with that component and themselves, so they have to learn. And that's how it works.
Thank you. So the knowledge is basically distributed between the teams.
Yes.
All the time.
And yes, and it's also one at the same time also a complaint that we have in reality with the feature teams and in less adoptions, is that people say, "Oh, I have to learn so much, and I'm never going to be able to be expert in that, etc." So this is a big challenge, and that the people see their profession in a box, and so in less, it's basically breaking down that box, and so which means that the profession becomes a job where you learn a lot. In fact, the job becomes less typically two-folded. One is you do your job, okay, based on your knowledge and experience, and but just as important that you keep learning. And so if you stop learning or improving, you basically killed your job. So you can be fired for that.
I'm afraid, Victor, that there's a threefold, because you need to teach others as well.
Yeah. Yes.
Thank you.
Hey,
1 minute.
So there's only 1 minute. Maybe anybody have any other question? Okay, so Victor, thank you so much for all your answers. It's very generous of you to answer so many questions tonight for you today morning, and we appreciate all your expertise and all your thoughts that you put into that. That it was been a great session. Thank you so much, and we would be happy to see you again at this meetup. And I would like to, after that, would like to get it back to David Nielsen to wrap that. Thank you.
Oh, I don't have anything else to say, but that was probably one of our most engaging talks. The most amount of questions answered. If by that metric alone, I think that was one of our best. So yeah, we'd love to have you back. Thanks a lot. Thanks everyone who was brave to throw your question out there tonight. It was really good. So thank you.
The questions are also really good. It kind of
yeah
engages a lot. Yeah.
Thank you,
right,
Victor.
And
Go ahead.
Ampersand, to answer your question, it says real men marry librarians.
All we could see was real men. What's this guy trying to say here?
My wife is the director of a library.
Oh, nice.
She makes me wear this in public audiences, I think.
That's a great shirt.
Yeah. Yeah, so a really nice session. Thank you for having me, and I'm happy to come back. So looking forward to it. And if you have additional questions, want to get in touch or stuff, feel free. And I guess you can find my information on a description or something, and it should be easy to find me. So Twitter, whatever.
Thank you. Thank you very much.
Can we post a video? Can you guys post a video?
Yeah, we're going to upload it to the cloud and then upload it to YouTube very shortly.
Thank you, sir.
So yes, and
Awesome
we'll put it in
talk.
the discussion chat of this meetup event. You'll get it. You should get a notification, but check back tomorrow.
Thank you.
Thanks.
Thank you, everybody.
Good night and good morning. Bye-bye.
Good night. Good morning.
Bye.
Bye.
Bye.